Okay, all right. Well, then let's jump straight in because we're starting a couple of minutes late. Tonight we are on our second to last lesson. No, sorry, I'm talking as our third to last lesson. We've already had 3 lessons where we've done the revision of grade 11 Euclidean geometry. We've discussed the proportionality intercept theorem. And now what we're going to do tonight is we are going to talk about similarity and the basics of similarity. Okay, so when we talk about triangles that are similar to one another, this has a very specific mathematical meaning, all right, which is important for us to know before we get started. All right, so if I say that 2 triangles are similar, what exactly do I mean by that? What does it mean if 2 triangles are similar? What exactly does it mean? Let's see in the chat. Same angles. Pinga, you're on the right track there. Maseko, when you say the same characteristics, you're there we go. All right, so different size. There we go. Chloe, 100% perfect. Okay, all right, so that is 100% perfect. So the word similar in maths, when we use it to describe triangles, means that all interior angles are the same, and the triangles have the same, the same shape. So I wanted to write the word same, but not the word shape. So the same shape. So it doesn't matter what sort of triangle it is. So in other words, I could have 2 similar right-angled triangles. And if I said that this was 90 and that was 40 and that was 50, I could have another triangle over here that's much, much bigger, but it's in proportion because the angles are the same. That's 90, that one's also 40, that one's also 50. Okay, so the angles are the same, all right, the same size, and they are the same shape. They are just different sized triangles. One is smaller and the other one is bigger. So again, I could be working in triangles that are shaped like this, for example. And let's say I say that that one over there is 70 and that one over there is 70. That means that this one over here would have to be 40 degrees. Okay, then I've got another bigger triangle. Okay, and that one over there could be 70, and that one over there could be 70, and that one over there could be 40. Then they would be similar triangles. Okay, so all interior angles are the same. They are the same shape, but they are different sizes. Okay, so very important that we understand that before we continue. Okay, how do we prove the triangles are similar? So there are 2 ways that this can be done. Does anybody know? How do we prove the triangles are similar? There are 2 ways. Does anybody know? You're welcome to unmute or put your answer into the chat. How do we prove triangles are similar, Matrix?
Let's go, my people. I know y'all know the answer. They'll go over me.
Go for it, Owan.
Ma'am, I would say you would find if the angles are equal or see if the ratios are the same, the ratios of 2 triangles.
Yeah.
Perfect. Owan, that's perfect. So either you are going to prove angle, 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 or you are going to prove that the corresponding sides are in the same proportion. Okay, so there's 2 ways that this can be done. Either we prove angle, 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 or we can prove the corresponding sides are in the same proportion. Now, when we are proving angle, 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 all the angles of a triangle always add up to 180 degrees. So in other words, if I want to prove that two triangles are similar to one another, all right, if I prove that this angle over here and that angle over there are equal, and then I prove that this angle over here and this angle over here are equal, I've actually proved similarity, because by reason of the fact that the interior angles have to add up to 180 degrees, it means that this angle over here in green and that one over there are going to be the same as well. All right, but I can only use sum of angles in triangle as my last reason. I cannot use it as my first or my second reason when proving similarity. Okay, but you're going to see more of that now in the examples that I am going to do. All right, the other thing that we need to talk about is what the word corresponding means. Okay, now I don't mean as in like corresponding angles when lines are parallel. Okay, that's something else. So when we were in grade 8, we had a transversal, we had parallel lines, and we said that this angle over here corresponds with that angle over there. Those are corresponding angles. But when I'm talking about corresponding angles and sides in triangles, this is what I mean. If I call that A and I call that B and I call that C, and this is D and this is E and this is F, okay, I would say that the corresponding sides are BC and EF, for example. That is because they are both opposite angles of the same sides. Okay, so sides are referred to as corresponding when they are opposite angles of the same size. So in other words, I say that, let me just rub out this over here because we're not working with corresponding angles, we're working with corresponding. What is my pad doing? Down. Okay, so I would say that side BC corresponds with side EF because they're both opposite angle A and angle D, which have the same size. Or I could say that side AB corresponds with side DE because they are both opposite angles that are the same size. In other words, angle C and angle F. Okay, so that's what we mean by the word corresponding sides. Okay, let's jump in and go and do an example and put all of this stuff into practice. Okay, so now when you are working with similarity, the easiest thing that they can do is an example like this, where they tell you which triangles you need to prove are similar. Okay, Lebogang, I see you've raised a hand. You're welcome to unmute and ask a question before I continue. Lebogang?
Lebogang, you are muted, so you need to unmute on your side. So there we go.
Sorry. Yeah. I'm asking to go back to the previous question.
Okay.
Yes.
Which one? This one over here?
Yeah. Can you please start to prove the angle A is this triangle, because I have load shaving there, so I couldn't understand.
I wasn't proving similarity. This is their first example that I'm doing. I was just explaining that if you've proved that two angles are equal to one another, the third angle will be equal because angles of a triangle add up to 180 degrees. And then I was explaining what we mean by the words corresponding sides. So sides are corresponding. Okay, so two sides and two different triangles are corresponding if they are opposite angles of the same size. So the example that I gave here is side BC And side EF, they are corresponding sides because they're both opposite angles, A and D, which are the same size. Okay, so I was just explaining some language and some words. I was just unpacking that before we actually get into the example. Okay, so you haven't really missed anything at all.
Oh,
Okay.
thank you.
No problem. All right, so the first thing that we always do in geometry is read the information that's given to us. So they tell us in triangle PST, which is the big triangle, TS is perpendicular to PS. So this sign over here, perpendicular, means that there is a right angle. Okay, and RQ is perpendicular to PT. Okay, so in other words, they've given us two right angles. The first thing that they want us to prove is that triangle PRQ is similar to triangle PST. So remember those three lines like that, that is the mathematical symbol for the word similar. All right. So the best thing for you to do is go and highlight the triangles with different colors. So I'm going to highlight PRQ in green. And I'm going to highlight PST in a different color. So PST is the big triangle. Whoopsie daisy. It's always difficult doing straight lines like this. Sorry, that's a bit of a mess. There we go. Okay, so now I have highlighted my triangles, right? And I know which triangles I'm dealing with. All right. In this case, they haven't told me anything about the lengths of the corresponding sides. So if they want me to prove similarity, it means they want me to do it by angle, angle, angle. Now, when they tell you which triangles to work in, they are giving you some important information. When they say to you triangle PRQ is similar to triangle PST, the order of the letters is very, very important. Okay, that means that angle P in the one triangle is the same size as angle P in the other triangle. And we can see that that's true because P is a common angle. They are also telling us that angle R in the one triangle is equal to angle S in the other triangle. All right, so in this case, it's angle R1 because adjacent angles on a straight line, okay, add up to 180 degrees. So if angle TRQ is 90, it means angle R1 is 90. Okay, so this angle over here and this angle over here are also equal to one another. And the same thing with the last one. Okay, so here angle Q would be equal to angle T. That is the implication. All right. The other thing that happens here is that we can make lengths of corresponding sides. So if triangle PRQ is similar to triangle PST, what that means is that we can say that PR, side PR, corresponds with side PS. So PR is the side over here, okay, the side over here, PS, its opposite angle, Q2. Okay, PS is this side over here, all right, and it is opposite angle T. And we know that angles Q2 and T are equal to one another. The same thing works with the other combinations of the letters. So RQ corresponds with ST. RQ is this side over here, it's opposite angle P, and ST is this side over here, it's opposite angle P, and they're the same size. And then we can do first and last and first and last. So in other words, side PQ is also equal to side PT. Side PQ is this one over here. Side PT is going to be that one over there. Okay, so both of those sides are the hypotenuse. They are both opposite the right angle in their respective triangles. Okay, so this is very, very, very important information that I'm giving you here. Okay, what you have to do after you've highlighted the triangles is go and look for the angles that are equal and figure out why this is true. Okay, so they are giving you some important hints. When we start our proof for similarity, it has to be done in a very specific way. We have to name the triangles we are working in. So we are obliged to write in triangle PRQ and triangle PST. First point, okay, we're proving angle, angle, angle. We can see that angle P is common. Okay, angle P is common. The second thing that we can see is that angle R1 equals 90 and angle S equals 90. So angle S1 equals 90 because of adjacent angles on a straight line. Angle S equals 90. Sorry, why did I write S1? Sorry, I meant to write R1, beg your pardon. R1 is 90 because of adjacent angles on a straight line. Angle S equals 90. This was given to me in the information. They told me that TS and PS are perpendicular. So now the third angle in the triangle, P is the same in both, R1 equals S, so Q2 and T are the third angles in the triangle. So I can say that Q2 equals angle T, angle sum in triangle. And this is what I was trying to say earlier. You can only use angle sum in triangle as your third reason. Okay, you cannot use it here in number 1 or number 2. All right, they will penalize you for that. It cannot be done. Okay, so if you've got 2 angles, you've proved it. The third angle will always be angle sum in triangle or remaining angles of triangle. Okay, once you have proved that the triangles are similar, you can now state, all right, therefore, triangle PRQ is similar to triangle PST, and then we mustn't forget our reason, angle, angle, angle. Okay, and that is the correct way in which to set it out. Okay, are there any questions? Bonga, I'm scrolling up so you can take a picture. I'll scroll back down again as well. How are we feeling so far? Is this making sense? Are we happy?
Thumbs up, thumbs down. I see Angela's like, ma'am, so far so good. That's good.
Go for it.
Ma'am, how do you go about answering question where they ask you to prove the theorem instead of proving that 2 triangles are similar?
Okay, so then Awam, that would be in your textbook and you would literally have to parrot fashion learn it and regurgitate it onto the page. So when you are proving similarity, you need the proportionality intercept theorem to be able to do that. And you have to do a construction as well. Okay, normally we never ever do constructions and caps, but when you're doing the proof of a theorem, you would do the construction. So yes, your teacher will teach you the proof of the proportionality intercept theorem. Your teacher will also teach you the proof of the similarity theorem as well. And either one of those two could be asked in trials and again in finals. So yeah, I'm not going to worry about proving the theorems at this stage. This is something that I always leave towards the end of the year, you know, when we're gearing up to write trials and finals. Okay, I don't think it would, I don't know about your school, but I know certainly at my school, it's not something that we test the matrics on too early, unless we tell them that we want to test them on it. Okay. All right. So there's some thumbs ups there. Let's now look at the next thing that they've given us. This means we need to show that the ratio of side RQ to PQ is the same as the ratio for ST is to PT. Now, in order to create these sides, there is another step that we need to do after we have proved similarity. So once similarity has been proved, we then have to do what I was showing you over here about working out which are the corresponding sides. Okay, so sorry, this was supposed to be number 3. All right, so in question C, which are the sides that are corresponding? So listen carefully, guys. The first 2 in this triangle were the first 2 in that one. So I'm going to write PR over PS. Then it's going to be the second 2 in the first triangle with the second 2 in this triangle. So here I'm going to write RQ over ST. And then it's going to be first and last with first and last. So that means I'm going to write PQ over ST. Okay, and our reason here is because they are the corresponding sides in similar triangles. So we say corresponding sides in proportion. Okay, in similar triangles, but you don't have to write that part. Okay, let's go back and have a look at what they wanted us to work with. So they wanted us to work with RQ. Here's RQ. They wanted us to work with PQ. Here is PQ. They wanted us to work with ST. Oopsie, I've made a mistake. Sorry. I beg your pardon. Over here, I wrote ST again. It's PQ and PT. Sorry, that should be PT. Okay. And then over here, you'll see it's ST is to PT. Right. So now we are going back to what we learned about proportions. Okay, do you remember our lesson when we first started proportionality intercept theorem? I said to you, you can write it as a ratio of the numerators to a ratio of the denominators. So in other words, if I've got 1 over 2 is 5 over 10, the ratio 1 is to 5 is the same as the ratio of 2 is to 10. Okay, so when we work with numbers, it just becomes a little bit easier for us to stand. I don't know if you remember that lesson, but that was something that we had discussed when we did proportionality. So now, based on this, I can then say that the ratio of RQ is to PQ is the same as the ratio of ST is to PT. The ratio of the numerators is the same as the ratio of the denominators. Okay, yes, you're quite right. It was PT. Good. Okay, next thing. Now they want me to work out PR times PT equals PQ times PS. So again, I'm going to go back to this original thing that I wrote. What do I want now? I want PR. There's PR. I want PT. Here's PT. I want PQ, which is this one over here. I want PS, which is that one over there. Okay, so now for the second part. What am I smoking? This is B. Sorry, guys. That's the only mistake I've made. This is now part C. Again, I'm working with my original corresponding sides in proportion. And I'm going to say that PR over PS is equal to PQ over PT, proved above. Okay, because I've proved that above in question B. And now I can cross multiply. So therefore, PR times PT is equal to PS times PQ. Okay, how are we feeling now? Thumbs up, thumbs down. Good, Angel. How's everybody else? You made it much easier. I'm so glad, Rebecca, because it doesn't need to be complicated. It doesn't need to be complicated. Lebogang, good morning.
We all have those days. As we'll do more examples, I'm sure Teacher Lee will.
We will. Yes, Lebogang. All right, so I'm giving you guys a chance to take more screenshots if you need to. And yes, I am going to do another example. Okay, so Katlejo's crying. Sehawu's not happy. Okay, all right, let's see if we can change those tears into a smile. All right.
Yeah.
Some of you may not have done this at school yet. Okay, which is the other reason why it might be difficult for you. Okay, but you need to have a good understanding of the proportionality intercept theorem in order to be able to continue with similarity. That's why they do proportionality intercept theorem first and similarity second. Okay, because we need the one to be able to do the other. Okay, so let's go down and go and have a look at this example over here, which I'm hoping you will find. Yes, exactly. If you understand that, Natalie, if you understand that they're actually giving you the answers, when they tell you which triangles to work in, they're actually giving you the answers. You just need to know the reasons. And if a reason, if something's been given to you, then the reason is given. You know, but you're going to need all of those reasons why angles are equal to one another that you learned from grade 8. So like alternate angles or corresponding angles or tan chord theorem or whatever it is. So that's what makes geometry a challenge, is because it is a collection of knowledge from grade 8 through to grade 12 that we are now applying when we get to do this. All right, so yeah, all the theorems that we've learned along the way are important. So in the diagram, they tell us PA is parallel to BC. Very important piece of information, because when lines are parallel, it means we can have alternate or corresponding angles, which are equal to one another. All right. The other thing that they give us is that angle B1 and angle C are equal to each other. So the first thing that they want us to do is prove that PAB, let's highlight it, is similar to triangle ABC. All right, so I'm highlighting the triangles. Let's use a different color. There we go. Okay, now what I'm going to do is I'm going to allow people that are feeling confident to attempt this on their own. Okay, it's exactly the same as the previous example, right? Almost verbatim. All right, so I'm going to allow you to practice this on your own. If there's anybody that doesn't know where to get started, is there, okay, let me put it this way. If you know where to get started, go ahead and carry on working. Is there anybody who's feeling confused at this point and doesn't know where to begin? You can just say me or something like that in the chat.
Yep, don't be shy. Remember, yes, Katlejo.
Okay, so
That's right.
Katlejo, Lerato, okay, me, okay, Unarini, if I said that correctly, Sihawu, Lesedi, Motso. All right. Okay. So there are a whole bunch of you that are saying, yes, you are confused. Fine. No problem. Okay. So all of you. Okay. So Shane, I don't know if the recordings from last year are available. Are recordings from the previous year available, Yolanda?
Yes. Yes.
Oh, okay.
Definitely.
All right, Shane, then go and have a look.
Possible.
I did a course last year, Shane, on grade 12 Euclidean geometry that was really, really extensive. I think it was about 12 lessons long. If you go and have a look at the previous year's work, so go and have a look at 2022. I've broken it down into understanding proportions and proportional intercept theorem 1 and then 2 and then exam questions and then similarity 1 and similarity 2 and then so go and have a look at those. Okay, you'll find the videos on
last year. Okay,
yes.
then I have to confirm. I'm quickly asking now. Sorry.
All right, yeah. So all of that, if they do have access to that, then you can go and have a look. Okay, so those of you that are confused, all right, we want to prove triangle PAB similar to triangle ABC, all right, and we're going to do it using angle, 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 because we don't know anything about the sides. So if we don't know anything about the sides, it's got to be angle, angle, angle. If they tell us the lengths of the sides, then we can use the corresponding sides in proportion. So the first thing that we want to do is write down our proof. So we're going to say in triangle PAB and triangle ABC. Now, when they give you the triangles like they've done here, they are telling you important information. They are implying that the first angle, angle P, is the same size as angle A. All right, so angle P in triangle PAB, which is this angle over here, is the same size as angle A in the other triangle. So that would be this angle over here. Right? Now, when we look at those two angles, we cannot see any immediate relationship between them. Okay, there's no tan chord theorem, there's no alternate angles, there's no corresponding angles, but that's fine. We're not going to allow this to upset ourselves. Now let's look at the next one. Okay, so now you're going to look at angle A in this triangle. So that's this one over here. And angle B in the other triangle. That's this one over here. Right? So now this is from grade 8. What can you say about A1 and B2? What can you say about A1 and B2? Exactly, Shoshana, exactly. There are alternate angles. And we know that alternate angles are equal to one another. So A1 equals B2 because they are alternate angles. And then we name the parallel lines. So PA parallel to BC. Cool. There's one more. Okay, because then we can conclude that the third pair of angles that are left over must be equal because of angle sum in triangle. So now go back, look at this information that was given to us here. They told us B1 and C were equal to each other. Okay. Yes, Natalie. Yes, that's exactly it. So if there's no immediate connection between the two, don't stress. Go and have a look at the remaining two angles and see if you can work with those. Okay, so we found A1 and B2. There is a reason why there. And then here, the second bit is going to be B1 and C. And that is because it's been given to us. So that's also really nice of them because it has been given. So now, Natalie and anybody else who's hopefully thinking like Natalie now we can conclude, all right, that angle P in triangle PAB and angle A in triangle ABC are equal to one another because of angle sum in triangle. Okay, so we've got angle P in the one triangle, and that's equal to angle A2 in the other triangle, and that is because of angle sum in triangles. The angles of a triangle sum up to 180 degrees. Okay, now, Tsegofatso and Offense, you are getting confused with congruency. Okay, congruency involves the sides. Okay, so we are not proving similarity by working with the sides. Okay, so the fact that AB is common to both in this situation does not help us to prove similarity. Okay, so saying that sides are in common is something that we use for congruency when we prove the triangles are identical to one another. Okay, so here they're not identical. Remember, they are same shape, but they are different sizes. Okay, so in other words, if you took triangle ABC and you put it down over triangle PBA, they would have the same shape, all right? But ABC is smaller than PAB. Okay, so yeah, give it time. We always need time for these ideas to settle in our minds and become things that we can accept and we can see. Okay, and Euclidean geometry is not easy. So now that we've got our three angles that are equal to one another, now we can write, therefore, triangle PAB is similar to triangle, and then we've got to have the correct order, ABC.
Nice. I think Tabang's hand has been up. I'm not sure, Tabang, is that a question or comment for Teacher Lee? You can unmute on your side. Okay, once Tabang is back, we can continue.
That's fine. See how you can, because it's the reason is the sum of the interior angles of a triangle sum up to 180 degrees. Okay, so there are 3 different ways in which this reason can be written. So it just depends on what your teacher has. Some people write interior angles of triangle. Angle sum and triangle is another one. There's a third reason. I can't remember it off the top of my head. Okay, but you can also here, if you want to, you can also say remaining angles of triangle, but you have to say of triangle. Okay, so the word triangle has to be in your reason. Okay, because it's not just the remaining angles anywhere. Okay, good. This is starting to become a little bit easier now. So there is our proof, angle, angle, angle. All right, we've proved 2 pairs of angles are equal, and then we've concluded, because the angles of a triangle add up to 180, that the remaining pair of angles must be equal to one another as well. Pleasure, Sehawu, no problem. Then for the next bit, B, we're going to use exactly what they gave us. So it's the first 2 letters over the first 2 letters. And the second 2 letters over the second 2 letters. And first and last over first and last. Okay, corresponding sides in proportion is our reason. Okay, and now you can go and look at what you want. So you want PA. Here's PA, there's PA. You want AB, there's AB. Okay. You want a PB. Okay, so maybe I highlighted the wrong AB there. You want PB and you want AC. Yes, sorry, I highlighted the wrong one. Beg your pardon, AB occurs in both of them because AB is a common side. So AB over there. The one that we were supposed to highlight was this one over here. Okay, so now again, they're asking us to compare numerator and denominator with with numerator and denominator. Okay, so what this means is that PA, therefore PA over AB equals PB over AC. And now I can compare the numerator to the denominator in the one triangle with the numerator and the denominator in the other proportion. Sorry, I said triangle, but I meant proportion. Okay, so in other words, if you have 1 over 2 equals 5 over 10, what we are doing here is the equivalent of 1 is to 2 is the same as 5 is to 10. Okay, if we were working with numbers. Okay, is that making sense, everybody? Are we feeling better about this? If we had crying faces earlier or feeling sad, is it a little bit easier to understand now? A little bit better. Okay, this is good. Fantastic. Okay. Okay, Zetu, I see you've got a question.
Ma'am,
Hello.
can you please explain B, the purple part?
Okay, all right, that's fine. So what I have done in B is they are asking me to write the corresponding sides in proportion to one another. All right, so how I get this is from the sides of the triangle. So if I look at PAB is similar to ABC, all right, if I consider a letter on its own, that's an angle. But if I put 2 letters together, that's a side. Okay, So the order in which it's given to you is important because the first two letters here correspond with the first two letters over there. They are corresponding sides. That's why I've written PA over AB, PA over AB. And then the second two letters over here, AB, correspond with those letters over there, BC. So that's why I've written AB over BC. And then first and last goes with first and last. So PB over here, which is that one, over AC over here, which was that one over there. Okay, then I have got the corresponding sides that are in proportion. Right, so because these triangles are similar, the sides, the corresponding sides are in the same proportion. That's what I'm writing in B. Okay, and then I'm looking at the question. I'm highlighting which sides they want me to work with. So it was PA and AB and PB and AC. That's why I highlighted them. Then I just wrote that over here. Okay, so this comes from here. They are equal to each other. And then I compared PA to AB is the same as PB is to AC. Okay.
Thank you, ma'am.
No problem. All right. I see there are more questions. We just want to do the last question here. So yes, who else has got their hand up? Katleho, go for it.
Ma'am, for number B, ma'am, the one that you just explained, ma'am, do you need a reason, ma'am? Do you need to write a reason?
Yes, so yes, Katleho, sorry, I'm interrupting you. This is the reason here, corresponding sides in proportion. Okay, so that needs to be written next to those three proportions over there.
Okay, ma'am, thank you.
Okay, no problem. All right, and again, I don't have to rewrite this. Now that I've written it once, I can use it to answer the other questions. They want me to use AB and AC. AC is over here, and they want me to use BP or PB, which is over there, and they want me to use BC. So now they're grouping those two together. All right, so that means that AB over BC is equal to PB over AC, which I proved above. And now I just have to manipulate it into what they want. Okay, so now here in this question, they want me to cross multiply to create a product. Remember, we spoke about that when we did proportions as well. Okay, so I'm cross multiplying. So therefore, AB times AC is going to be equal to PB times BC. All right, and then I'm done. Okay, yes, cross multiply. Okay. Pinga, good, yeah, lovely. All right, so Pinga, normally when they ask you to prove similarity, it would be out of 3, possibly 4 marks if it's more complex. So here it would be statement reason. Here it would be statement reason, and then there would be a mark there. So that would be out of 3. Then here there would be a mark for the statement, a mark for the reason, and then a mark on that. And then here it would be the same thing. There would be a mark on that statement. And then there wouldn't be a mark there because that's what they asked you to prove. So something like this is probably out of 3, 4, 5, 6, maybe 7 marks for this whole thing. Okay, so it's quite a substantial amount. I don't know, Katleho, we need to find out because if those videos from last year are available.
They are. I did find out.
Are they? Did you find out? Are they available? Brilliant.
Yes. So you can watch them either on YouTube or on the website. So it's just up to you, but they are available, all of them.
Yeah, yeah. So if I just show you very quickly over here, this was what I did last year. Okay, so you can see here this grade, this is what you'll be looking at. So there was revision of grade 11, then there was advanced questions on grade 11, understanding proportions, proportionality intercept theorem, converse proportionality intercept theorem, similarity, and then loads of exam questions that I had done as well. So yeah, go back and watch all of those, and yeah, that should help you. Okay, so yeah, it was an extensive course. Okay. Okay, so Sibongile, I've just said proved above. Okay, so in other words, in part B, I showed that PA over AB is equal to AB over BC was equal to PB over AC. So your reason here is corresponding sides in proportion. Okay, because the triangles are similar, their corresponding sides are in proportion. So what I've written here that's maybe not very clear to see is this: corresponding sides are in proportion. Okay, and that's in similar triangles. Okay. Yes. Yeah, so that's why I've said it's proved above, because I've proved it in the previous question. Quite right. Okay. No problem. Okay. All right. So the second question would be homework for you tonight. The third question, let's see if we can quickly do that before we go. We did start a couple minutes late, so I'll probably end off at 7 minutes past 4 because we started at 4 minutes past 6. All right, so what I want to do is give you an opportunity to try this on your own. All right, if you can only do part A, then that's fine. Only do part A. If you're a fast finisher and this is making sense to you and you want to do part B, go for it. That's not a problem either. Okay. Let me just make it a little bit bigger. Okay, so please do part 3, or question 3.
Lebohang, is that hand to ask a question again, or you forgot to put it down?
Oh, I'm getting lost to questions, the previous question C. When the mem explained that we multiplied AB times AC is equal to BP plus times BC. So my question is that it was not supposed to be AB over BP is equal to AC over BC because we did cross multiply.
I'm not following you, Lebohang. What are you asking exactly?
Oh, ma'am, I'm asking that you said in question C, we multiply.
Yes.
So, yes. The question is, it was AB times AC. It's equal to BP times BC, right?
Yes.
So I'm asking to the point of that, if I wrote like AB over BP because we did cross multiply, it's equal to AC over BC. Is that correct?
If you write AB over PB equals BC over AC, that is correct. You can write that as well, absolutely. But then if you've got, let me just write that down because that is true. So you said AB over PB is equal to BC over AC.
AC.
Okay, but now, yes, that's fine. That's fine. That's perfect. Not a problem.
Oh, yes.
Yep, 100%.
Okay, so the ratio is gonna be the same.
Yes, it's going to be the same. It's going to be the same because the numerator of the one over the numerator of the other is the same as the denominator.
Okay, thank you, ma'am.
No problem. There we go. Now everything is in the middle of the screen. So yeah, you can screenshot this, and then at least it means you've got something to try at home as well.
Yeah, I did really, really well today. I believe you guys learned a lot of things to digest, but still you nailed it. Well done, guys.
Yes, Angel, we'll mark this homework. I'll give you the answers next time.
Oh, Teacher Lee, do we still have one more to do, the 3A?
Oh, yeah. So once they've done 3A, they can try 3B.
Okay, okay. No, it's because, yeah, I made a mistake of posting a link because I thought we had done.
No. So I just want them to try A and B. If
Okay.
they've only managed to do A in the time that we mark it, then that's also okay. But I thought there might be people who are fast finishers. And if anybody is a fast finisher and they want to start on the homework now, that's fine. I'm just giving you a little bit of time to work. And then I'm going to interrupt you in about another 2 or 3 minutes. And then I'm going to go through the solution to 3A and 3B. Okay, so is there anybody that's managed to prove that these triangles are similar to one another? So Mbali, you're saying, can you say that G2 is equal to C? Yes, Mbali, you can. You can and you must.
Ma'am,
Yes, Katleho.
ma'am, can I be brave and try to give you the answer?
Go for it. Oh, please do. We love hearing from you guys. Go for it, Katleho.
But ma'am, I don't know. EC equals to FG.
Okay, so which angles can you say, because remember we're working in triangle BEF and we're
Yes,
working
ma'am.
in Okay, and then we're also working in triangle FGD. So I'm just going to highlight those. So which angles do you think are equal in these two triangles?
So ma'am, I think triangle F3 equals to angle F3 equals to angle B.
You're right, it does, but you can't start with that. What would be the reason that they were equal to one another?
That's why, ma'am, I was like, so ma'am, I started with the line EC equals to FG so that I can prove that BE over FG equals to BF over FD, ma'am.
Okay, but you're going to want to do that in the second part of the question. In the beginning bit over here, you want to work with the angles. All right, so if you have a look, some of the people on the chat, okay, are saying, can I say that G2 is equal to C? Yes. F2 equals G2. F2 equals G2. So F2 equals G2 because they are alternate angles, but F2 is not inside one of the triangles. Okay, so exterior angle of triangle. All right, Kotwano, you're on the right track. There are some corresponding angles here. So the corresponding angles that we are supposed to see is this angle over here, F1, and that one there at D. Okay, so in other words, the F is lying on its side over here with its arms out there. Can you see that? Okay, so here we would start with F1 equals D because they are corresponding angles. Okay, that is because side EF is parallel to side GD. That would be our first starting point. Okay, or we could have started with this one. So angle E1 is corresponding to angle C, and angle C is corresponding to angle G2. So therefore G2 and E1 are equal. So here we would set that out as follows. We would say that E1 equals C because they are corresponding angles, because EF is parallel to CG. But angle C equals angle G2, also because they are corresponding angles. And now that is because CE is parallel to GF. So if angle E1 equals C and angle G2 equals C, it means that angle E1 is equal to angle G2. Okay, so E1 is equal to G2 because they're both equal to the same thing, which is angle C. So now, Katleho, now we can go and say, therefore, angle B equals angle F3. Okay, and that is because of the angles in a triangle. Okay, so therefore, triangle BEF is similar to triangle FGD. Now I see Nolutando, you've got a hand up. You must also write AAA afterwards as well. Go for it, Nolutando.
Hi, ma'am.
Hi.
I wanted to ask if it's possible to say angle B is equals to F3, angle F3 because of corresponding angles, because BEC is parallel to FG.
Yeah, you're right, actually. You're right. Yeah, absolutely. Sorry, I was being very, very silly about that, of course, because, hang on a second. Yeah, quite right. We could have, so Katleho, I was wrong. You could have started there. Absolutely, absolutely. Sorry, that was very silly of me not to see that. So, Nolutando, you are saying there's the arm, and there's the arm, and there's the back over there, and that angle over there and that angle over there are corresponding. Absolutely, absolutely. So here, what we've done here is fine, but we could have used this as a reason, or we could have started here and we could have used corresponding angles as well. Yeah, absolutely. Well done, good spot.
Oh, well done, everyone.
Very
Then I'll
nice.
type this.
Yes, you could have. Okay, so you can say that B and F3 are corresponding angles, Kutwano. That's absolutely fine. Okay, Lebogang, E1 and G2 equals 90. No, you can't say that. We don't know that we've got any right angles here. Are there any other questions that we can just take quickly before we say goodbye? Anybody else got a Lesedi? Go for it.
Hi, ma'am. Can you hear me?
I can hear you, Lesedi. Please ask away.
Can we also say angle F2 is equals to angle G2 alternating angles because EF is parallel to GD?
We can, but angle F2 is not inside one of the two triangles that we're working in. Remember, we're working in this triangle over here and this triangle over here. So saying that angle F2 is equal to G2 doesn't help us unless, of course, you can say that F2 is equal to something in this triangle over here, which if you had then gone and said that angle F2 over here is equal to angle E1 because of alternate angles, that's okay. You could do that.
Okay, thank you.
Okay, not a problem. Okay, Fencer, okay, you can ask the same question to Bang. Oh, okay. Ma'am, is it also okay to use E1 and F2? Yeah, absolutely. Absolutely, you can do that as well. So E1 equals F2, alternate angles, because BE is parallel to GF. And then you could have said that F2 equals, yeah, absolutely. Absolutely. Okay. I'm so glad you guys are looking at different ways of how we could do this. Okay, that's very good. Well done.